Up next, a keynote on electrifying aviation, defending today, decarbonizing Irsud tomorrow. To unpack it all, I would like to invite Daniel Rosen Jacobson, co-founder and CEO of Elysian Aircraft.
Thank you. Hi, I'm Daniel Rosen Jacobson, co-founder and co-CEO of Elysian Aircraft, and we are indeed making electric aircraft technologies. I'd like to start with a bit of a personal story of how I got into this. So I don't know, and I know it's early, and I see also a little bit of mixed ages in the room, but I don't know if people remember this aircraft here on the left. Maybe with a show of hands, who has flown in a propeller aircraft in general? I mean, yeah. So it's actually less than you would expect, about half the room. This specific aircraft is a Fokker 50, F50, and since I was a little boy, I actually flew in this aircraft because my father built this specific aircraft with this specific branding, this airline, I mean not this aircraft, over the 90s into a regional small airline. So as a young child, I flew in this aircraft. I also got to sit in the cockpit many times, and I could overlook, the world from the air, and it definitely planted a seed into, what aviation could mean for the world. I didn't go into aviation despite my father's business ventures. I spent some time at Google, and I also built a software video streaming startup up to a global scale-up and an exit. But eventually the pool became bigger, and I met these two guys on the right of me in the picture on the right, both aerospace engineers, much smarter than me, and we ended up founding an electric aircraft company. Which is Elysian. And it really was founded on the basis of two insights. I think the first insight, and keep in mind that aviation or aerospace is always active in both defense and in civil industries. There is a massive addiction to fossil fuels in aviation, and it's very hard to solve that because, in the air, it's not so easy to work with other energy sources. And that dependency or addiction to fuel, fossil fuel, means, emissions, it means noise, it means heat, and those are things that are kind of in the way. It is in the way of decarbonizing, it's in the way of noise, making a lot of noise, and it's also in the way of, a number of things that are relevant for the defense industry. It's very detectable, it makes noise. You see it now in Iran, for example, where the Reapers are not really effective anymore because they're spotted and then they are taken out. So this is like a bottleneck that is shared between those two industries. I think the second insight is that aviation is local, very local. So a lot of flight activity happens at short ranges, so up to 1,000 kilometers, about half the world's flights, up to 2,000 kilometers, about 80% of the world's flights. And there's a lot of CO2 intensity relative to the flight distance. 20% of total aviation CO2 emissions come from those short flights. I think another insight is that at those short flights, the aircraft being flown are not necessarily those propeller planes that I showed, around 50 passengers, etc. Those are really kind of been phasing out slowly over the last 10, 20 years, and they're predominantly now narrow bodies. So, everybody will probably know a Boeing 737, Airbus A320. They're sort of the most profitable planes in the world. They can actually fly 6,000 kilometers, but they are used for short haul as well, 500 kilometers, just from economics perspective. So any concept that wants to tackle this needs to be competitive with those aircrafts on a per passenger basis. And so that's how we got to our aircraft. Our aircraft is an invention fully validated by universities and research institutes, including the Technical University in Delft and DLR in Germany and MIT. It is a 90-passenger aircraft that can travel 800 kilometers purely on batteries with battery technology of today. So no new chemistries. We do need some improvements in efficiency, but within the lithium chemistry sphere. With new technologies like solid state, we might be able to go up to 1,000 kilometers or beyond. So what makes this aircraft unique and possible? Well, first of all, it looks conventional, but it isn't, in the sense that it has a very large wing and a small fuselage. It has batteries integrated into the wing, and it's large, it's heavy. So for a 90-passenger plane, it's as heavy as a Boeing 737, which has twice the amount of passengers. And it has a very large wing, as I said, and the batteries are integrated into the wing, and that's also part of our core IP. The second thing is that we have multiple engines, also something you can see straight away. That is to distribute the power, and it allows us to both optimize for efficiency and also noise. The third is a high voltage system. The fourth is a reserve energy system, because we use a turbo generator system just for reserves. Again, it's a more optimal solution than carrying that in battery weight. And finally, reusable battery packs that we develop ourselves, which allow for a very reusable and circular swapping of batteries every year. These technologies are what we are developing in-house, and they also have an application outside of our own aircraft design, the E9X. So they allow for certain UAV applications. They're effective also for hybrids. They also need batteries. They also need power systems. We actually do a project now with a company called Conscious Aerospace, partially paid by the Dutch government, and in a hybrid fuel cell. So both hybrid electric and hybrid fuel cell. A little bit of our timeline. So we started as a project in 2021. Then we founded the company in 2023. We then went on to validate it, and we are now in a preliminary design phase. And currently, we are actually turning these ideas into physical technology demonstrators. In fact, very recently, we did our first flight of our scaled demonstrator. We also have a power distribution rig, which is a one-to-one scale wing with the power distribution system into our workshop. We have a wing integration mock-up where the battery systems also at one-to-one scale are tested. And we build our own battery modules, which we're testing, including thermal runaway tests, which we recently completed. I now think we have a small video, which I'd like to cue, of the first flight. So this is a roughly 8% scale, 7.5% scale of the eventual plane, but the full form and exact shape, form factor of what it will eventually be, of course, scaled down in terms of performance of things like batteries and engines. But a big milestone for us, and something that allows us now to test a lot of things, including aerodynamics and software. So what does this actually mean if you can achieve this? Of course, we need to look at two main things. One is how clean is it? So for that, we did a research with CE Delft, which is a research institute, which looked at all the different options of traveling across those distances up to 1,000 kilometers. And actually, across the life cycle, so including production, including infrastructure, our aircraft performs the best per passenger per kilometer. So it is actually the cleanest way to travel. It even beats, if you include infrastructure, the electric train, if there are no train tracks. Then the second thing is, of course, the economics. Operational costs need to be lower than the alternatives for airlines to be able to adopt this. We've built an extensive economic model, which shows that the aircraft on a per passenger basis beats the regional jets straight away, and with higher fuel prices beats the narrow bodies. And actually with today's fuel prices, which of course are unique because of the situation in the Middle East, but it would be already competitive today. And in time, we think also things like SAF cost and charges for fossil fuels will make this happen. Well, we are at an energy conference, so I also wanted to say something about the energy source and the charging. So we've done a research report on this around the future of airports. And so the charging capacities needed for this are large. They're around 15 megawatts per aircraft. But these are technologies that already exist. We can use MCS standards, and they exist in shipping, mining, and trucking. And we've actually seen power units that can achieve what we need to do. There are also some benefits from installing this, being able to optimize daytime versus peak versus low peak, or low demand, doing stationary storage, and other benefits. We have some really key partnerships. So we announced a co-development partnership last year with KLM. We also work with a leasing company called True North, and we're increasingly getting support from the industry at large. We have a great team of about 30. Many of these people are aerospace engineers or people from the aerospace industry and have worked on aircraft programs, both in civil and defense aerospace. Finally, we are currently raising a round. We're raising a Series A. Investors get a real opportunity here to have a meaningful impact and with time remove 2 gigaton of CO2 by 2050. We have a strong IP portfolio contributing to the wide electrification of aerospace and a 10+X return. We already have first commitments and evaluations set, and we are looking to close in the next months. So we're really interested to connect with investors or partners who are interested to join us in this. Thank you very much and enjoy your conference.